Hello everyone, welcome to Vectorly. Today we are going to solve a few more kinematics problems from Pathfinder. These problems are quite a bit higher level, so let's do it with a bit more cautiousness. A horizontal wax bar B rests between a wedge and a vertical wall as shown in the figure. The wedge starts moving towards the wall with a constant acceleration of 0.5 mm per second square. The moment the wedge starts moving, continuous supply of heat from the wall starts melting 1 length of the wax bar per second. If the bar always remains horizontal, which of the following conclusions can you make? The first conclusion is the bar first moves downwards and then upwards. Let's check this later. This wedge moves in this direction with an acceleration of half per second square, whereas this wax bar melts down in this direction by 1 per second. Now, let's fix our frame of reference with respect to this horizontal wedge. So, let's draw it. Let this be the initial position, and let's consider this to be the final position. Okay, so the delta S will be this. I'm considering delta S as this. So, delta S is now, if you notice that if the bar is melting, if this bar is melting down, it comes down. So the delta S would increase. So this delta S is increasing because of this rate 1 per second. That is nothing but this velocity. So 1 into t plus the same amount as this length reduces, delta S comes here. At the same time, because of this wedge moving in this direction, delta S is will decrease because this will move upwards. So delta S would be negative. That is, or else it will decrease. So minus half a t square. What is the acceleration? Half t square. It is actually retardation here. Now this delta S should be positive for any point when this block is relatively lower when compared to its initial position. So delta S is greater than 0 at which time we are going to check it. So delta S is nothing but t minus t squared by 4. When is it greater than 0? Of course, it should be greater than 0. So t into 1 minus t by 4. Of course, t is greater than 0. So t should be less than 4. At t equal to 4, delta S is 0. That means this wax bar comes to the same position as the initial position at t equal to 4. Now, at any point less than t less than 4 and greater than 0, delta S is positive. So, from this we can conclude that initially the bar goes down and then it moves upwards because again at t equal to 4, it is at the same position, same initial position. So, the option A is correct. What about option B? Let's verify. A bar stops for a moment after 2 seconds from the beginning. For this to happen, the critical point of this function delta S should be 2. T equal to 2 should be the critical point because at the point the direction changes. That is, delta S becomes an decreasing function from an increasing function. So let's find the derivative and find the critical points. First, the derivative of d by dx dt of delta S is 1 minus t by 2, which is 0 at t equal to 2. So at t equal to 2, it changes its behavior. That is, it becomes decreasing function from an increasing function. So it should stop at this time. So option B is also correct. the modulus of displacement of the bar in first 4 seconds. We observe that after 4 seconds from the starting, there is no net displacement. So modulus of displacement is 0. So third statement is false. The first statement, distance traveled by the bar in the first 4 seconds is 1.2 mm. Let's calculate what distance it moves at t equal to 2. The same distance it moves after at t equal to 4. That is twice of the distance traveled between t equal to 0 to 2 is the total distance traveled between 0 to 4. So let's take, this is delta s. This is the y we have to calculate. This angle is 37 degrees. So this is supposed to be 37 degrees. So tan 37 degree, which is 3 by 4, is equal to y by delta s. Now y is 3 by 4 delta s. What about delta s? Let's calculate at t equal to 2. Delta s at t equal to 2 is 2 minus 1, which is 1. So from this we can conclude that y is equal to 3 by 4 millimeter. And twice of his distance is traveled at 4 seconds, first 4 seconds. So 2i, that is the required distance. D, which is equal to 2i, which is equal to 3 by 2 mm, which is 1.5 mm. But it is given as 1.2 mm, so it is also false. This is the way of approach for these kind of questions. Let's go to the next question. Let's go to question number 2, which says that two motorboats that can move with velocities of 4 meter per second and 6 meter per second relative to water are going upstream in a river. When the faster boat overtakes the slower boat, a buoy is dropped from the slower boat. After lapse of a time interval, both the boats turn back simultaneously and move at the same speed relative to the water as before. The engines are switched off when they reach the buoy again. If the maximum separation between the boats is 200 meter after the buoy is dropped and water flow velocity in the river is 1.5 meter per second, find the distance between the places where the faster boat passes by the buoy. Actually, the buoy is something which can float. Okay, let's consider this as the river, and let's this be your starting location where initially the boats are at the same position. Okay, boat 1, let this be boat 1, this be boat 2, which moves with 4 meter per second, and this moves with 6 meter per second in still water, whereas water is going with 1.5 meter per second, and the buoy is just dropped right now. Okay, now what are we going to see is, let's start, mark this time as t equal to 0. That is t equal to 0. Now it is telling that the maximum separation is 200 meters. Now if we consider a frame of reference as this boat, then we will observe that this boat is moving with a speed of 2 meter per second as a relative velocity. Correct. So the maximum distance is 200 meter, makes that at t equal to 100, the distance between them is 200. Correct, right? Because the relative velocity. So at t equal to 100, the relative velocity is 2 meter per second. So the distance of separation is 200 meters. After t equal to 100, they must turn back. That is, it should go somewhere else and come here, and it should go till here and come here. This time, when this boat, the faster boat reaches this point, is 100 second, t equal to 100. At that time, this boy would go. Its speed is actually the velocity of the stream, which is 1.5. So it would go 150 meters. Okay. Now, what? Let's calculate the distance traveled by the faster boat. The relative speed is nothing but 4.5 meter per second, and the time is 100, so it should be a 450 meter path. 450 meter, and the boy at this first place came to 150 meter. Now its speed is 6 plus velocity of stream, and the boy's speed is, what is the boy's speed? Its velocity of stream. So the relative velocity is 6, and this relative separation is 600 meters. So this, the time taken by the faster boat to again catch the boy is again 600 meter by velocity 6, which is 100 seconds. So at t equal to 200, the faster boat reaches the boy again. So from initially from this position, it will again travel 100 seconds. So that is 1.5 meter per second into again 100 second, which is 150 meters. So this boy would move again another 150 meters. So a total of, it would be displaced by 300 meters. 150 plus 150, that is 300 meters. Here we have telling calculating this time with the faster boat or the river as a frame of reference. Okay, but the final distance we are using the ground as a frame of reference. Let's go to question number 3. A semi-cylindrical groove of radius r equal to 20 centimeters made on a horizontal floor. An ant wants to cross the groove. A boy decides to help the ant, making a bridge consisting of straight wire segments. But all the wires available are of length 38 centimeter. So the boy rigidly connects two wires at right angles and places a bridge in the groove as shown in the figure. If ant can crawl up a wire segment at speed v equal to 0.5 centimeter per second, down a wire segment at down a wire at the speed of 2v, in what minimum time can the ant cross the groove with the help of the bridge? So let's calculate it. First, let's draw it again. Now, this is r and this is r. So the total distance is maximum is 2r, which is 40 centimeter. But the maximum length of the wire is 38 centimeter. So we can't completely place a wire to join this. That would be a simpler case. But you properly know, if you properly notice this question, you can notice that no matter what the angle of the taper is, the velocity of the ant climbing the incline is always v. Whereas in coming down the incline, it's always 2v. So we have to maximize the length for coming down. So the maximum length of coming down is 38 centimeters. Correct? So this length should be 38 centimeters. So let me use some variables. This is it. This is distance is 2r. Let this be L and this be, let's this be L1, this be L2. We will get L1 square plus L2 square is equal to 4r square by Pythagoras theorem. Let this be equation number 1. And what is the equation 2 that we have to minimize is the time. The time taken is L1 is covered with speed 2v plus L2 is covered with speed v, and this should be minimum. So the time t should be L1 by 2v plus, what is L2? Root over 4r square minus L1 square by v. Now we have to substitute the values. That is, it's just an intuition that 38 centimeter would work. So 38 by 2 into v half plus under root 4 into r square is, so it would be 400,600. So 1600 minus 38 square will divided by v, that is become 2, which is 38 plus 2 into under root 40 square minus 38 square. So 98 into 2. Let's calculate it, which will become approximately, sorry, I made a mistake. It is 78 into 2. That is root over 156 minus L1 square, 1640 square, 78 into 2. That is nothing but 156, twice of root of 156. Sorry, I made an error. 12 twice is 24.9. This is approximately 38 plus 25, which is approximately 63 seconds. Let's go to the next question, which says a marble is projected in a viscous fluid with an initial speed u at an angle theta above the horizontal. Drag force of the liquid results in an acceleration of a drag, which is minus k times the velocity vector. In addition to that of gravity, where k is a positive constant and v vector is the velocity of marble. Determine position coordinates and x horizontal and v vertical components of velocity of the marble as function of time t. What is the terminal velocity? Let's calculate. Let this be the floor of that container, and let's mark here the initial velocity is u and it makes an angle theta. The initial velocity vector u vector is nothing but u cos theta I cap plus u sin theta into j cap. Now the acceleration vector is minus k at any particular instant vx be the, okay, let me define it. V vector is vx I cap plus vy into j cap at any instant. So k vx I cap minus k vy j cap, and again acceleration due to gravity, which is minus g j cap. Okay, so what next? Um, okay, so at any particular instant, velocity in y direction is nothing but u sin theta minus kvy plus g into t. Correct. So vy plus kvy t is equal to u sin theta minus gt. So velocity in y direction is nothing but u sin theta minus gt by 1 plus kt. Now, what else will I get? But this is a differentiable form. This can't be written in this way. This is a wrong method of approach because at any every particular instant the acceleration depends on the velocity vector. This is a rough approximation value. So the exact value should be written as exact method is, it's not a value. The exact method is dvy by dt is equal to minus, because of the sign, g plus kvy. Okay, so minus dvy by g plus kvy is equal to dt. Now, upon integrating both sides, what you will get is minus vy. Sorry, what I get is minus t is equal to 1 by k log of mod g plus kvy. With limits, the initial value of vy is u sin theta and final value is Vy. So what do you get? Minus kt is equal to log of g plus kvy whole divided by g plus u sine theta. So what do we get is e power minus kt is equal to g by kvy into g plus u sine theta. So Vy I get as g plus u sine theta into e power minus kt minus g whole divided by k. Okay. Now similarly let's calculate Vx, velocity in x direction, which is nothing but first dvx by dt is equal to minus of k Vx. So we can write as log Vx is minus dt with at particular instant Vx. Initially it's u cos theta. So it would become log, it is minus k dt, log Vx by u cos theta is equal to minus kt. Initial time is 0 and at particular instant it's t. The similar is applicable here. So Vx is u cos theta into e power minus kt. I'm skipping the most basic steps and all. You just take care of it. Okay. This is Vx and this is Vy. Now, what else should we focus is determine the position coordinates and velocity of the as a function of time. Velocity of a mammal in horizontal and vertical direction as a function of time, we have did it. For position coordinates, we have to simply integrate those points and you will get it. Okay. I'm leaving that part to you. Now we have to find the part at which it attains terminal velocity. The concept of terminal velocity, most of you might have known it. It is after a particular instant. This happens in a by Stokes' law actually. If a body is there, a spherical body, if it is put into a container containing a viscous liquid, after a particular instant, it goes with a constant velocity. That is constant velocity, which is termed as terminal velocity. So, what can we say is this terminal velocity is the velocity at infinity too. We don't know exact time at which this terminal velocity becomes the velocity becomes constant, but we can be sure that at infinity, at t equal to infinity, the velocity is the terminal velocity. So we can apply limit v tends to infinity to Vy to obtain Vy terminal, which is limit t tends to infinity of Vy, which is nothing but limit t tends to infinity g plus u sine theta into e power minus kt minus g by k. So this would become Vy terminal is as t tends to infinity, this terms becomes e power minus kt. The graph of e power minus x would be like this, and this term becomes approaches 0. So what we get is minus g by k. Similarly, V x terminal is u cos theta into e power minus kt. which is nothing but that becomes limit t tends to infinity u cos theta into e power minus kt. As e power minus kt tends to 0, the whole term tends to 0. So v terminal is nothing but vy terminal, which is nothing but minus g by k. This is the final terminal velocity. Let's go to question number 5. An aircraft is flying at a level height in a straight line when you see it at an elevation of 53 degrees above the horizontal. But you hear its sound coming from an elevation at b is equal to 37 degrees above the horizontal. When the aircraft passes a location vertically above your head, its angular velocity relative to you is omega is equal to 1 by 8, that is 0.125 rad per second. Speed of sound in air is 330 meter per second. If transit time of light from aircraft to you is negligible as compared to that of the sound, calculate altitude of the aircraft. In this situation, let this be your ground and let the aircraft move in this path. Let the man be here. Initially, he's seeing the aircraft. Let the side be negligible. This be the altitude. He sees the man notices the aircraft when it is at an angle of 53 degrees. But when the sound reaches him, it is at an angle of 37 degrees. Okay. So let this distance be x1 and this whole distance be x2. Okay. And let this height be h. Okay. Now the distance traveled by the sound is this one, correct? Which is L. Now this 53 degrees is alpha, so sine alpha is equal to h by L. Also, we have another data that's omega is 1 by 8. Now we have it is the value of omega when the v velocity is, let the velocity of the aircraft be constant v. So v is equal to omega into h as it is a perpendicular. So v is omega into h. So this can be written as v is equal to h by 8. We have this equation and we have this data too. Now, what? Now let's equate the time taken for the aircraft to cross this distance and the sound taken to cross this distance. First, the time taken by sound to cross this distance is the length L by the velocity of sound, which is h by sine alpha into velocity of sound, which is Vs. Now the same time is taken to cross this x2 minus x1 distance by velocity of the plane, that is v. Now we have to calculate this x2 minus x1. What is x2? X2 can be given as, let's write this, tan alpha is equal to, first let's calculate x1. Tan alpha is nothing but h by x1. So x1 is equal to h cot alpha. Similarly, x2 will be h cot beta, and x2 minus x1 would be h times of cot beta minus cot alpha whole divided by v. V is nothing but h by 8 and 8 h by vs sine alpha. But we have to calculate the height. So let's cancel this. So height is nothing but vs sine alpha. Let's write this as omega itself. Omega into h. So into cot beta minus cot alpha. If we put the values, we get the final result, and then this is the calculation. This is the final part. You can calculate and evaluate the answer. There are much more good Pathfinder questions. We will do it later in this segment. Okay. If you have any doubts, mention it in the comment section. We would try to solve it within a day. Thank you.